Listen, folks, this gets very serious when NASA targets school children to indoctrinate into climate disinformation. We've got to put a stop to this.
A simple definition of a contrail is a cloud that forms in the wake of an aircraft. More specifically, this cloud is a water cloud, so it's either composed of water droplets or ice crystals. And the contrail was evolved sometime around the World War II, and it's a shortened version of the name condensation trails. So what is happening here are the gases, exhaust gases, water vapor from the engines of the aircraft are condensing. That is, they're changing from an invisible gas, water vapor, into a solid form. That is the ice crystals. Some other names for a contrail are, you may have heard of vapor trails or jet trails. And more recently, some people who believe that there's a sinister conspiracy behind these clouds are as chemtrails. They're ice crystals. One thing we want to point out is contrails have been around for a very long time. Almost since the introduction of aircraft, there have been contrails. The first description in the scientific literature was shortly after World War I. And in World War II, this is a scene over London during the Battle of Britain. And here we have the evidence of a dogfight between British Spitfire and Messerschmitt Bf 109. So sometimes you would actually see contrails littering the sky during aerial combat. Now, to make a cloud, there are many ways we can make a cloud, and generally the process when clouds form are that the water vapor in the air has to condense into visible water droplets or ice crystals. In order to do this, the humidity in the atmosphere has to reach 100%. And this condensation can occur in two ways. One way is to increase the water content in the air. This generally is kind of difficult to do. The other way is to cool the air so that the air reaches its dew point temperature. As you might know, the capacity of the air to keep the water inside it is dependent on temperature. So as you cool the air, the capacity becomes less. Thus, some of the water has to go out of the air. It condenses, forms either liquid water or ice. There are many ways to make a cloud, and most of the ways that these processes involve that second part, cooling the atmosphere to make a cloud. Now in contrails, it's a little bit different. Nearly all the contrails that you'll see in the sky are formed by the mixing of the cold outside air with the wet exhaust of the jet. This is what's called a mixing cloud. What happens is, as you burn the jet fuel, one of the byproducts of that combustion is water vapor. Another example of a mixing cloud that's very common is when you go out on a cold winter day, you'll sometimes have a cloud form on your breath. That is the same process that's producing the contrail. Now I want to talk a little bit about mixing clouds and why they're important. Here is, if we look at this plot, we have a plot here. On the vertical plot, we have moisture in the atmosphere. So as we go up, this is greater, increasing amounts of moisture. This way, on the horizontal axis, we have increasing amounts of temperature. This line right here is what's called the saturation vapor pressure curve. What this means is, at this particular temperature, TB, we can go up to this point and say, we're going to get, if we had this much moisture, we would have saturation. So as you can see, this say we date the measurement of the air temperature right here at EB. We can see that it's below this line. That means it's not saturated. The relative humidity is less than 100%. Now let's look at this line. Over here, we have a temperature TA. We have the air temperature here. And you can see that this curve becomes very steep right here. So what this says is, as temperature increases, the capacity of the air to hold water vapor increases much faster than just a straight line. It's an exponential growth, in fact. In fact, to give the example of breath, if the air temperature were around 20 degrees Fahrenheit, and you took a volume of air equal to the size of your breath, the amount of water vapor that could hold is only 1/16th the amount of your breath. So you can imagine that on a cold winter day, your breath is much moister than the air in the atmosphere. Now when you breathe out, those two, your air and the air outside, will mix together. And the temperature at some point, if they're equally mixed, will be somewhere in the middle, this Tc. But the amount of moisture we see is halfway in this halfway point as well. But this curve is not a straight line. So what happens is, even though we have the outside air, which is not saturated, there's no clouds in the outside air, and your breath, just as it is, won't produce a cloud, the mixture will produce a cloud. And this is the remarkable thing about mixing cloud, is that the mixing air, neither of them have to be saturated, but the mixture combined together will produce a cloud. Now this is probably one of the reasons why people have been talking about, wondering about contrails in the sky, because they can appear on otherwise cloudless days. You'll see this cloud appearing in the sky. And you'll think, well, there's no other clouds in the sky. How could the relative humidity be 100%? How could this cloud form? And as a result of this special process, this mixing process. So nearly all the contrails that you'll see in the sky are of these mixing cloud type. And what I want to point out is that these contrails are at very high altitudes and they form at very cold temperatures. And the reason for that is because contrails do not always form from jet aircraft. If the air temperature is a little bit too warm on the outside, the atmosphere, it won't be able to cool the exhaust enough to create that condensation. Likewise, if the atmosphere is too dry, you won't get a contrail forming. So that's why contrails don't form all the time. Another thing to remember when this jet is flying overhead, it's not only putting this moisture in the atmosphere, it's putting heat. So there's actually a competition factor. There's the one factor that's helping to form clouds, that's the water vapor in the exhaust, but there's also heat in the exhaust. So that's another reason why you don't see contrails all of the time. So why do we study contrails? Historically, in the past, the military has almost always been interested in the study of contrails because contrails cause what I call detection and visibility problems for aircraft. As you can imagine, if you have a convoy, this is a picture from World War II, a convoy of bombers, you get these huge streams of contrails forming, and this causes problem. There have been reports from World War II of bombers not being able to find the target because there are just so many clouds being formed by the contrails. In fact, there have actually been collisions between aircraft in the sky as a result of not being able to see the contrails. Also, on the other way, some fighter pilots have actually used contrails to their advantage by hiding in these clouds and then popping out and ambushing other aircraft. On a more modern note, astronomers don't like contrails. That affects their visibility to make observations into outer space. So they'd like to see as few contrails as possible. Now at Langley, we're interested at climate research, and so we were interested in those contrails that may have an effect on climate. And the ones that are most likely to affect climate are the ones that are persistent, that stay around, hang around for a while. As you know, many of the contrails you see are just a little short trail. They may last for, less than a minute. Some contrails, however, will continue to grow and spread. And this is the result of the moisture in the atmosphere. If the atmosphere is moist enough, the contrails will start to take up some of the moisture from the water vapor surrounding the clouds. And as you can see, these contrails will continue to not only persist, but actually grow larger in time. And persistent contrails occasionally cover very large areas. This is a picture over Nova Scotia. And you can see this is along a major airline route between the United States and Europe. And contrails are very much, in terms of their radiative property, are very much like cirrus clouds. They're high in the atmosphere, they're very thin. So what happens is, like all clouds, there are two effects that contrails or any other cloud has on the climate. One is to reflect solar radiation back to space, and the other competing effect is trapping heat, infrared radiation. It turns out, like cirrus, contrails generally have a little bit more heat trapping effect than their solar reflecting effect. So we currently estimate that the contrails, based on how many we can see and measure, probably add somewhere between 0.5% to 5% to the warming compared to the greenhouse gases. So if the the warming caused by greenhouse gas were 1, we would say that the contrails are either 0.05 or 0.005. Now, 0.5%, that's pretty small. Even 5%, that's a small effect. But why are we even worried about these? One of the things we expect in the future is that air traffic, and as a result, persistent contrail coverage will continue to grow. So this is an estimate that's been made of the air traffic from 1992. And this is based on how many aircraft were flying at that time and the conditions in the atmosphere. We know, depending on the temperature, the relative humidity, and the altitude that the aircraft are flying, we can get a good estimate of where contrails should form. So as you can see, in 1992, the highest traffic areas where we get significant traffic, more than, say, 1% coverage at all times, only occur over the United States and Europe. If we look 58 years in the future, to 2050, we estimate that this area will continue to increase, and these maximum areas will become even larger as well. So by 2050, the warming may be anywhere from 2.5% to 25% compared to current global greenhouse warming. Now note, this is a very big range. 2.5% is still not big enough to really worry too much about, but 25%, that's now becoming a significant fraction of the greenhouse warming. Now, yes?
Is that the Bermuda Triangle?
Oh, right here?
Yeah.
There's
to the right of that, where's blue? I mean, it's like...
Oh, that's Bermuda's probably somewhere out here.
Oh, okay.
But there's no Bermuda Triangle there. So one of the reasons why we can't pinpoint exactly how much effect contrails have on our climate is that we still have trouble estimating basic properties of contrails. Contrails are very small things. This is a high-resolution satellite image over Wisconsin and the western Great Lakes, and you can see many little contrails forming here. Unfortunately, contrails only last for maybe a few hours at most, and these high-resolution satellite images, they might come around maybe twice a day. So we're not capturing all these images of contrails throughout the day. In order to do that, we currently have to rely on geosynchronous satellites. And this is our best attempt at getting a picture from the geosynchronous satellites. As you can see, we start losing a lot of detail in terms of not only the number, but the thickness of these contrails.
Now, O'Hare's a busy airport, but a lot of the contrails are north of that. Is that because the planes
Right. There are most of the contrails that you see are not from planes that are landing at various airports. They're actually the ones that are flying at high altitudes. Remember, these contrails have to be formed at very high altitudes and very cold temperatures. So this is a major airline route to Japan, I think, right here. So that's why you see all those contrails there. So in order to get a better handle of how many contrails there are, we're now starting to use inventories of these commercial air flight data that are now available on the internet. So you can actually figure out where all the aircraft are flying. And in this case, I've run a simulation where I've taken those flight tracks and tried to match them with individual contrails. The surface observations from school will help us in our studies because they'll be able to tell us more about where the contrails are at that we can't see from the satellites. Now I want to finish off with what I call contrail cousins. These are contrails that appear, atmospheric aircraft-related phenomena that appear that sometimes some of them are mistaken for contrails, and some of them are unusual forms of contrails. So first of all, I'm going to talk about what I call unconventional contrails. These are all clouds and could be called contrails because they are all condensation trails, but they're not the typical mixing cloud. So what we have here, we have a couple jet fighter, and you can see a little stream of clouds coming off the wingtips. You can also see these clouds sometimes in the rotors, not only of helicopters, but also propeller airplanes as well. And finally, this is a jet fighter, and it's breaking the sound barrier at this particular point. And what you see actually here is a shock wave as the aircraft is passing through the sound barrier. So the pressure waves that are created here are creating alternate areas of compression and expansion, and where air expands, we get this cloud. So all of these are created by a slightly different process than we do with the regular mixing clouds. These are produced in relatively moist conditions, and as you can see, in low altitude conditions sometimes, and they're almost always short-lived. As you can see, these things don't last very long, and they're pretty tenuous. These are some pictures of not contrails. If you look at some of the big jet aircraft, this in particular is a B-52 on takeoff, and you can see these streams of dark smoke coming out of it. And that's what they are. These are actually smoke from the engines of the aircraft. They're not contrails because they're not water clouds.
Just like dirty exhaust.
It's dirty exhaust, exactly. Some of these, I don't know if it's because the size of the aircraft and the fact they have to take off with so much power, or whether the engines are just old, but you'll sometimes see that. Also, skywriting planes produce something that looks like a contrail. It's white like a contrail. It's coming out of the exhaust here of the aircraft, but it's not a contrail. It's actually a type of smoke. What they do is they have a special type of oil, similar to cooking oil, that's burnt and sent out the exhaust, and it's biodegradable and breaks up in the atmosphere, but it's great for making skywriting, but it's not a contrail. And then finally, aircraft sometimes do the opposite. Instead of producing a cloud, They actually take a cloud away. They make holes in the cloud. Here's an example of a jet aircraft flying over a bank of clouds. And the downwash, as the airplane is flying above this cloud, you can see these rolls here. It's sucking drier air from above down, and this drier air is actually dissipating the contrail. Dissipating the cloud below it. And here's another example of jet aircraft that have flown just above the tops or maybe just in the cloud. And as a result of this downwash from above, we're getting holes in the clouds.
Listen, folks, this gets very serious when NASA targets school children to indoctrinate into climate disinformation. We've got to put a stop to this.